through question 8 of block test time trial, paper 2. Let's take a look at the question. Right at the top, the question says that you should state the parameters of any distribution that you use. Alright, so we have to bear this in mind. The question started with describing the context. A manufacturer produces specialist light bulbs. The masses in grams of one type of light bulb have the normal distribution and 51.5 square. You have to sketch the distribution for masses between 40 and 60 grams. Okay, let's take a look at the solution. Before we draw the normal bell curve for part 1, we need to define the random variable. Okay, so please be mindful about that. Let X be the random variable that represents the mass of light bulb in grams. For normal distribution, always remember to state the units of measurement. Then after that, you should also identify and state the normal distribution. So for this case, mu will be equals to 50 and sigma equals to 1.5, where mu and sigma are mean and standard deviation. Should spell in full. Okay, let me rewrite again. Standard deviation of the masses of light bulbs in grams respectively. So we are following the instruction given by the question because the question requires us to state the parameters used by the distribution. Okay, since probability of X between 40 and 60 is 1, using GC, this means that when we draw the bell curve, the shaded area between 40 and 60 should be the entire area under the normal distribution curve. And furthermore, because 50 is the mean of the normal distribution, and 40 and 60, they are in equal interval from the 50, right? So 40 is 10 units away from 50, and 60 is 10 units from 50 on the right hand side. So which means that because 50 is the mean, this means that the probability of this area and this area will be the same, right? About the symmetrical about the bell curve. And moreover, not only that, this part and this part will also be symmetrical. So when you draw the bell curve, not only these two regions, let's say I call it as A and B, they must be of equal area, but also the unshaded region must also be the same, right? Okay, so let's move on to question 8 part 2. Find the probability that the mass of a randomly chosen bulb is less than 50.4 grams. It is a 1 mark question, so it should be quite simple. So px less than 50.4, you can easily use norm CDF to help you find the answer using GC. Okay, so that one I'll leave it to you to check. Then before we move on to part 3, the question gives us another piece of information. Each light bulb is packed into a randomly chosen box. However, the masses of empty boxes also have a distribution, which is a normal distribution with mean 75 to square variance. Now, the question for part 3, it asks us to find the probability that the total mass of 4 randomly chosen empty boxes is more than 297 grams. So take note, it is talking about boxes, no longer light bulbs, and there are 4 of them. So in order to compute this probability, we do have to define another random variable. So I let Y be the random variable that represents the mass of an empty box in grams. Okay, make sure you include the units of measurement. So y follow a normal distribution 75 2 square as given, and there are four of them, so it should be y1 plus y2 plus y3 plus y4. Okay, if you want to calculate the mean, you should always do it in a space outside, and each of them, because each of the y1 to y4, they have identical distribution, so it is equals to 4ey, which is 300. And for the variance, if you want to calculate, it's the same. All right, so it is 4 variance y, which is 16. So take note for this case, it is y1 plus y2 plus y3 plus y4, because we are talking about total mass of 4 empty boxes. Please do not use 4y. Okay, so 4y is wrong. 4y means you have one empty box and you're considering a very huge box, which is 4 times the mass of a typical empty box. Okay, but physically there's only one giant box. But for here, we're talking about total mass of 4 randomly chosen boxes. So it should be y1 plus y2 plus y3 plus y4. So take note of this. Then for part 4, find the probability of total mass, again, of a randomly chosen light bulb and a randomly chosen box, and find the probability it lies between 124.9 and 125.7. Okay, so in this case, because it's only one light bulb and there's only one box involved, so when we find the distribution, we should have only x plus y. So you can also find the mean and variance by using ex plus y equals ex plus ey, and you can find the variance x plus y equals variance x plus variance y. Okay, so with this you can find the answer, which is mean 125 and variance is 6.25. And from here you can use your GC to find the end answer, which is 0.126. So relatively, the part so far covered so far are quite simple. Okay, now we move on to the last part of the question. In order to protect the bulbs in transit, each bulb is surrounded by padding, that means a cushion, before packed into a box. And now the padding, the mass is not insignificant. It does have its own uh, weight as well, mass as well. So the mass of the padding is modeled as 30% of the mass of the light bulb. So in other words, if we consider the mass of the light bulb, it should be the light bulb plus the padding, it should be 1.3x. Okay, because the padding itself is uh, 30% of the light bulb. So if you consider them as a whole, all right, it should be 1.3x. All right, then the question asks you to find the probability of total mass of a box containing a bulb and padding is more than k grams. This probability is given to be 0.9, and with that you have to find k. Okay, so first of all, we have to find, it is better to define the random variable. So I let W be the random variable that represent the total mass of a bulb with padding and an empty box. So in this case, your W is 1.3x plus y. And how do you find the mean? The mean would be 1.3ex plus ey, which is 140. You can check. For variance, W would be 1.3 square variance x plus variance y, which is 7.8025. Okay, so take note there is a square here for 1.3. So knowing that probability of W more than K is 0.9 is given. So using inverse norm, all right, inverse norm from the graphing calculator, rounding off to three significant figures, I should have K equals to 136. Okay, so please check. Okay, now part 6. Find the probability that the total mass of 4 randomly chosen boxes, each contain a bulk and padding, is more than 565 grams. Okay, so with that, we know that there must be a new random variable because a new distribution is involved. So we have defined a random variable which includes the bulk with the padding. But now I have four of them. So which means that I need a new distribution, which is W1 plus W2 plus W3 plus W4. Okay, and you can find the mean by taking EW1 plus EW2 plus EW3 plus EW4. Okay, so this is the same as 4EW. That is the mean of W1 plus W2 plus W3 plus W4. Let me write in a space further away. As for variance, you can do the same thing, but because each of the W has the same distribution, so it's 4 variance W, which therefore give us 31.21. All right. So being more than 565, again using graphing calculator, we have the answer as 0.185. All right, so with that, we have completed the review of question 8. On the whole, the question is not difficult, but just that when you solve the question, you have to be very careful in calculating the mean and variance, and always remember if there's a need to define a new random variable, like what happened to y and w, you have to do it. Okay, please do not use the same random variable throughout. And you notice that as we transit through the question, there are many different distributions. So every time after you found the mean and variance, please remember to state the distribution. Okay, it is very important that the final normal distribution must be stated. Okay, and you're working for the mean and variance, you should also show it clearly. Okay, try not to do within the normal distribution itself. Okay, try to do in a space outside. Okay, so that to make your solution neater. So with reference to this, you can refer to the actual solutions to have a better idea how you should work out a question like this. All right, thank you.